All right, so yesterday we were talking about scalar vector quantities. We looked at the different point of views if we had like a simple trip of what it would look like from a scalar point of view when we talked about distance and speed. Okay, we looked at how it would look from a vector point of view with displacement and velocity. Okay, and we found that they can be quite different if it's not a straight line, okay, or if there's any changes in direction. All right, then we did a couple of problems that were fairly simple at the end of the day, okay, involving assigning a positive and negative value to different directions. All right, we're going to kind of continue on with that a bit today, get a bit more practice, so review using b equals d over t, and then next week we'll move into like more complex vector related stuff. Okay, so question number 3 is something we didn't talk about yesterday. We did talk about 1 and 2, but question number 3 we didn't. Okay, the significance of a reference point. Okay? We actually had a couple of questions where a reference point was important, but we didn't talk about it. Okay? And that would go back to this question. What's the reference point for this question?
The statue.
Yeah, the initial is the reference point. Because the initial position, we were told, was 1.5 meters to the right of the inukshuk. That makes the inukshuk the reference point. Okay? So the reference point is not always your initial position. Sometimes it is. Okay? But often it isn't. It's just the thing that your initial position is measured from. Okay? And then you kind of go from there and you draw your vectors as arrows and you put them tail to head like we showed yesterday. Okay? Or the day before if you were here on Wednesday. All right, so with that in mind, what I would like you to do is try and draw the seating plan in question number 4. Okay? And think about who is the reference point. All right, so first off, who is the reference point? Dolores is the reference point. I don't know where to put Chad unless I put Dolores somewhere. They don't tell me where Dolores is. I just have to kind of stab a D on the page and go, all right, I'm going to measure everything from here. Okay, does that sort of make sense? All right, so we would just set Dolores down, maybe arbitrarily kind of close to the middle, okay? And then say, all right, Chad is 2 meters left of Dolores. Okay, so here's Chad. Okay, Ed is 4.5 meters right of Chad, which means he's 2.5 meters right of Dolores. Okay. Okay, and Greg is 7.5 meters left of Chad. So and Hannah is 1 meter right of Ed. Okay, so that's what my seating plan would look like. Agreed? Okay, so all that, I mean, obviously that question is not mathematically challenging or taxing in any way. The trick is, what's the importance of a reference point? What do you do with your reference point? Well, you measure at least the first thing you get other than that from there, and then it establishes where you can put everything else. Okay, so it's important to always kind of figure out where is my reference point in a question. All right, so what's the displacement of a teacher who walks from Greg over to Hannah? Okay, 9.5, 12, 13 meters to the right. Okay, would be her displacement. Okay, I want you to try number 5, keeping this formula in mind. Okay, so in this question here, they tell us that the person's displacement, they actually give me D, is 50 kilometers west. Okay, and I'm looking for the final position, and they give me that their starting position is 5 kilometers east. Okay, so I have the initial position, I have the displacement, and I'm looking for the final position. So all I have to do is manipulate this formula by doing what with pi? Adding it over to the other side. All right, so I'm going to take my displacement, I'm going to add my initial position, and that's going to give me my final position, right? What do I need to keep in mind when I start putting numbers in here? Direction. Okay, west is usually negative, okay? East is usually positive, but whatever you assign to it is fine. I'm just telling you that most of the time we treat a compass like we treat an XY plot, okay? This is positive. This is positive, this is negative, that's negative, okay, just kind of goes that way. All right, so what I'm going to do is I'm going to take my negative 50, okay, and I'm going to add 5 to that, okay, which means my final position is 45 meters west of whatever my starting, or my reference point was, okay. Pretty okay with that one? Was that a lot like the ones we did yesterday? Okay, now, number 6 looks deceptively easy, but there's something you have to be mindful of in that question, so read it carefully and give it a try. All right, we got the ball traveling, okay, from one person to the other. So they're standing 3 meters apart, and the child on the right tosses the ball. So this is the starting point of the ball, okay, with the child on the right. So they pass it to this person here, okay, and then the person on the left tosses it, and this person has to move all the way over to here in order to get it. Okay, so determine the horizontal distance and displacement of the ball. So what's the total distance traveled by the ball?
11.
Okay, 11 meters, because we got to go 3 meters and then 8 meters. Okay, what often happens is people forget that from here, the ball has to go all the way over to here. Okay, they often just say it's 8 because they go 5 and 3. Okay, forgetting that the ball has to traverse this 3 meter section twice during that part. Now, what's its total displacement? 5 to the right. Right, 5 meters to the right, because displacement is vector, and we have to have that on. Okay. Manipulation. You just want to put this out there. If anyone struggles with algebra, okay, this course is like, we use algebra every day, all the time. Okay? So this is something you're not going to be able to do. Okay? If you use a triangle to help you do algebra, I have very, very, very bad news for you. This is about the only formula. I'm sorry, there's 2 other formulas out of like the 30 formulas we use that this will work for, okay? Every other formula, there's no triangle for. Like, for example, when we do this formula. I don't know that there's even a shape for that. I don't know if even a trapezoid would work there, okay? Like you have to be able to do algebra to do physics, because this is just not going to cut it, okay? You have to be able to manipulate equations, right? So remember, there's only 3 rules to manipulating an equation, okay? If I want to move something, I do the opposite operation. What I do to one side, I have to do to the other. And the 3rd rule is you move what's not attached to what you're looking for first. Okay? If you remember those 3 rules of algebra, you will be just fine. Okay? If you can apply those 3 rules of algebra, you will do even better. Okay? They got me through university physics. Okay? Right up to the point where it became calculus and I was lost. But okay, it works for all things linear at least. Okay? So if I want to manipulate this equation here to get d, what do I have to do?
Multiply.
Multiply both sides by t. Whoops. Okay, everybody all right with that? All right, what if I want to solve for t? Yep, bring v over here. Okay, now, would that answer have been the same if I started it like that? It better be, because if you divide both sides by d, what are you solving for? 1 over t, which is not the same thing. Okay, if I start this out and I divide both sides by d like this, there's a 1 here now. Because when I move that d, I'm essentially going d divided by d, and I make it cancel. But d divided by d is 1. The 1 stays on top. Okay, 1 over t is not the same as t. Because that's like saying 2 is the same as 1 over 2. And the last time I checked, 1/2 and 2 are not the same number. Okay, in the same way, 1 over t and t are not the same number. Okay, so we have to be mindful of that. Okay, the rules of algebra, just follow them, and you won't have any struggles in this class at all. Okay, everybody all right with that? Okay, so all the stuff we've done so far, the questions have been like, it was just this, and it was this, and calculate this. Now I want to look at trips that have multiple parts, where you have to find like an average, okay, over the whole trip. So what we have to understand is this formula here, as well as this formula here, actually mean this. Average velocity equals total displacement divided by total time. And we haven't had to worry about that because we've only had one time and one displacement in all the questions we've done thus far. But if I have a question that has multiple parts to its trip, then I might have to go, okay, I had a displacement of this much in part 1 and a displacement of this much in part 2. What's the total displacement over the whole trip? Oh, and part 1 took this long and part 2 took this long. What's the total time for the entire trip? I have to combine them in a question like that. Okay, now you did questions like that in Science 10, but we haven't done one like that yet today. So I want you to try this question here and see how you do with it. Knowing, as this hint, you're going to need like a part 1, a part 2, and a totals kind of thing. So I would set it up and break it up that way. Okay. So the way I would start this would be that I would write down all of my givens. The question says that the truck first travels at a velocity of 4.0 meters per second north for 12.5 seconds. So I have the velocity and the time for part 1. Okay. In part 2, it travels for, it travels 26 meters south at a velocity of 16 meters per second. Okay, so I have the displacement and the velocity in part 2, but not the time. Right? To do this question, yep, right there. So what I'm looking for in this question is the average velocity and the average speed, which means I need the total displacement and the total time, and I need the total distance and the total time. Okay, that's how I would start it at least. Okay, now obviously there's something in part 2 that I need, and there's something in part 1 that I need in order to get the stuff I need for the totals. Okay, so there's a number of kind of intermediate calculations that you have to do before you can get to getting the average velocity and average speed. Okay, give you a couple more minutes, see if you figure it out, and then we'll walk through the rest. Let's start with calculating the average velocity, because that's what we need. Okay, if I'm going to get average velocity, I need the total displacement and the total time. So that's going to mean the displacement for part 1 plus the displacement for part 2, okay, divided by the time for part 1 plus the time for part 2. Okay? I mean, that's how you get totals, right? You add things together. So I don't have the displacement for part 1, but I do have the velocity and the time. Can I get it? Yeah, I just have to use v equals d over t. I just have to manipulate it so that I'm solving for d. D equals v times t. Okay, I plug in my numbers. Okay, that'll be 4 meters per second times 12.5. That should give me 50 meters if I shouldn't do math in my head, but I'm pretty sure that's what it is. Okay, 50 meters north. Okay, now I've got the displacement for part 1. Do I have to do something similar for part 2? What do I have to find for part 2? The time, yeah. Okay, so I just go t equals d over v. Okay, and I'll get 26 divided by 16. That one I'm not going to do in my head. All right, so 1.625 seconds for that part. Okay, I've got the time for part 1, I got the time for part 2, I got the displacement for part 1, I got the displacement for part 2. I can do this. Now, that can get me the average velocity, so that'll get me part A. Right, so my average velocity will be positive 50 plus negative 26, because I'm going to make south negative, or you can just go minus 26. Okay. And then for time, I'm going to take the 12.5 seconds plus 1.625 seconds, okay, and then I'll have my average velocity. So 50 minus 26, I can't believe I actually just typed that in, but I did. Divided by 12.5 plus 1.625. Also can't believe I actually typed that in and screwed it up on top of it. Okay, so I'm getting an average velocity here of 1.7 meters per second. It doesn't have a negative, so that would imply that it is north. All right, so my average velocity then comes out to 1.7 meters per second north. Okay, what do I need to change to get the average speed?
You won't have to take into account direction.
Right.
So instead of subtracting a 26, like for average velocity, you can just do your speed. So you don't have to take into account the south direction of the 26.
Exactly. So now to get speed, I'm just going to go 50 plus 26. Okay, there's no negative involved. This is how far did it go? It went 76 meters. Okay, and how long did that take? 14.125 seconds. Yeah? Yeah, so.
Yep.
And again, dangerous for me to do things in my head. Okay, so if we do that, 76 divided by 14.125. All right, so we have an average speed of 5.4 meters per second. Okay, we haven't talked about significant digits yet. Some of you may have already learned about those. Okay, I'll quickly go over those next week. Okay, but this should have 2 significant digits. Okay, for our answer. All right, everybody okay with how that one works? Okay, so if we're ever asked to get the average for a trip that has more than one part, that's how we go about doing it. All right, in your digital workbook, there are a few just kind of practice v equals d over t questions. So I'm just going to call those up. There they are. Okay, so I'll make it a bit bigger. You guys can call this up on your phone as well. I think all of these ones are scalar on this first page. Okay, let's have you guys just do number 3. Number 7. and number 8 for now. Okay, just try 3, 7, and 8. Direction is not important for any of them because it asks, well actually for number 8 it asks for velocity, but everything is north, so it doesn't make any difference anyway. Okay, so if we're looking at number 3, okay, we've got the trick with number 3 is we have to make our units match. Okay, I can't have kilometers as a distance and meters per second as a velocity because they're looking at the same trip, but they're looking at it in different units. So I just have to convert the kilometers to meters, and then everything should work out. Okay, so in part 1, okay, I've got a displacement, or actually a distance in this case, 11,000 meters. Okay, and a speed, it says velocity, but it's actually a speed, 21 meters per second. Now my units match, now I can perform mathematical operations with them. Okay, and then in part 2, I've got a distance of 1,000 meters, okay, and a speed, it says velocity, but it should say speed, 4.2 meters per second, right? So now everything matches. Now I should be able to calculate the velocity of the bus for the entire trip, provided I get something for each of sections 1 and 2, and it's the same thing. What is it? Time, right? Okay, so in order to get time, I just manipulate t equals d over v. Okay, so for part 1, that'll be 11,000 over 21. Okay, so that's 523.81. And for part 2, 1,000 divided by 4.2 is 238.10. Okay, now, what I'm doing on the board is not the same thing I'm doing in my calculator in terms of this rounding thing that I just did here. Okay, whenever we're doing mathematical operations in physics, we keep all the decimals. I'm just too lazy to write them all down on the board every time I do a calculation because it's self-defeating. Okay, so now that I've got the times for both sections, now I can go to here and go average speed equals total distance over total time. My total distance is 12,000 meters. And my total time is whatever 523.81 plus 238.10 is. Okay, so I just go 12,000, okay, divided by, and then I just take these two numbers, put them together. All right, so 16 meters per second.
I put 238 instead of 2. I mean, I put 283 instead of 2.
Oh, okay. It's always something simple, right?
That's what I put.
Question?
Could you take your time as like a decimal number? Like, cause with mine I still got 15.75, but I took my time like without converting it, and then I just got like 0.5238, and then when I did 12 divided by, when I added them both up to like 0.761 continued, I still got it.
Oh, and you left it in kilometers.
Yeah.
Okay, so you had, I guess you had it in kilometers per second.
Yeah.
Yes. Yeah.
Okay.
Yeah, that's fine. Okay, everyone all right with that? So I mean, you did keep your units the same, you just converted your speeds to kilometers per
Yeah.
second. Yeah, that's fine. All right, how are we doing with number 7? How many people have done 7? Okay, do we need to go over 7? Or? Some people are working on 8 right now. Okay, is that one a little trickier? Okay, so the hint I'll give you for 8 is you have to work backwards a little bit. You have the information for the whole trip. You can use that to figure out the part that you're missing. Okay, so rather than adding it all up to get the whole trip, you already have the whole trip. You have to go backwards to get part 3.